Hey guys, I wanted to finish the hypothesis test video with a special kind of two proportion z-test. Usually in every case, when we're doing a two proportion z-test, we get a fraction. In other words, we may get something that says in a random sample of 62 people, 47 people responded a certain way. Well, in this case, on a very recent AP statistics exam, they gave you a probability problem that only had percentages. And I want to show you what you would have to do if they gave you percentages, because you have to remember that in our calculator, the proportion has to be a whole number divided by a whole number. Otherwise, your calculator will give you an error. So let's try this problem together. Tumbleweed, commonly found in the western United States, is the dried structure of a certain plant that are blown by the wind. I believe it's pronounced cachia. A type of plant that turns into tumbleweed at the end of the summer is a problem for farmers because it takes nutrients away from soil that would otherwise go to more beneficial plants. Scientists are concerned that cachia plants are becoming resistant to most commonly used herbicide, glyphosate, I guess. Okay, sorry about that pronouncing. In 2014, 19.7% of 61 randomly selected cachia plants were resistant to glyphosate. So here, guys, in 2014, I wrote p hat to be 0.197, and I did 1 minus p hat, which is the q hat, 0.803, and n equals 61. A lot of times you have to stop and just extract the data. So once again, as you notice, is we don't see of the 61 randomly selected plants, 30 of them or so on. So this is a different type of problem that we're used to. So they said in 2017, 38.5% of the 52 randomly selected cachia plants were resistant to glyphosate. So here's 2017, here's your p hat. And remember, p hat is either a fraction or a decimal, not both. I hope everybody watched all my videos. Okay, so it's p hat's 0.385, 1 minus p hat's 0.615. The question says, do the data provide convincing statistical evidence at the level of alpha equal 0.05 that there has been an increase in the proportion of all cachia plants that are resistant to glyphosate? So my HO would be there is no difference between the two proportions. And my HA, guys, is going to be less than, because if you're looking for an increase in the proportion, then you want your arrow to be greater than for this guy. In other words, the second in 2017, that's what we should be greater than. Remember to define your parameters, okay? The proportion of all cachia plants that are resistant to glyphosate in 2014 is what we will call P1. And P2 would be the proportion of all cachia plants that are resistant to glyphosate in 2018. Remember, anytime you guys are doing a hypothesis test, just stick to the script, 5 steps. The first one's the hypothesis, we're done. The second one is our conditions. Here they tell you it's random, and here they tell you it's random. Both of these tell you it's random, so that's great. Now we have to actually physically tap our decimals and multiply it by n to get your greater than 10 part. So I put here the stem of the problem states that the plants were chosen randomly, and this should say both. I should be really checking my spelling or what I'm writing actually. And both 2014 and 2017, I should put in. And since the successes and failures are greater than or equal to 10, we could assume the distribution is approximately normal. Typically, we have n. Typically, it would be like 61 times 20 out of 61, and that's 20. But in this case, we don't, so we have to actually work out the problems, okay? So I did it for you guys here. 61 times 0.197, okay, remember, n times p, n times 1 minus P, or Q. N times P, N times 1 minus P. So I did those here. This is 12.017, this is 48.983, 20.02, 31.98. All of these are greater than 10. Therefore, we can assume it's approximately normal. Now, this is what I meant by we can't use our calculator for this problem to give us our p-value and our z-score. Because in our calculator, we have to put the x and the n. If you try to put the x and you want to be exact, it would be 12.017 and 61. Now, I'm sure they'll give you full credit if you actually put the 12 over 61. But I just want you to know that if you want the exact value, you're going to have to do it by hand and not use your calculator for the p-value. All right, so I did all this by hand. You will get something very, very close if you did 20 out of 52 as p hat 2 and 12 out of 61 if you did p hat 1, okay? But I hope you understand why you can't do it. It's because x is a whole number, it's an integer, and this, your actual answer is a decimal. So let's move on to the z-score. The z-test is p hat 1 minus p hat 2 divided by, in my last video I showed you for a 2-sample proportion that we have to get this new guy, p hat c. P hat c is taking the x's in both cases and adding it, and taking the n in both cases and adding it, and then dividing those two values. Well, remember our x is this guy and this guy. X is supposed to be a number. So I did that here for you guys, and I got that answer to be 0.2835. Then I did 1 minus p hat of c, and I got 0.7165. And then I did 1 over 61 plus 1 over 52, and I got this guy here. So I'm just doing all the values together. And then once again, I should change. This guy here is this guy here. And I just took my time with the calculator. I did step by step. I did the numerator, and I got this. Okay, let me choose a different color. And then I did the denominator, and I got this. Okay, let me just get rid of that. And then I divided, and I got this. And because it's a one-sided test, and because this is a negative, and the negative and the less than is good to go, I looked this up on my table, and I got this. Or you can, if you don't want to look it up on your table, you could press second vars, normal CDF. Your lower could be like negative infinity if you want. I mean, you would pick, we know that z-scores don't go past like negative 3.5, so I chose negative 5. This could be negative 6, negative 10, negative 1,000. Doesn't matter. Your upper is this guy, right? Because remind yourself what you're looking for. This is negative 2.21. You want this p-value here. 0, this is standard. Your mu and your sigma is 0. And then you get a p-value of 0.0136. Or guys, you could just look it up on your table. Fine. 0.0136 is less than 0.05. Since the p-value is less than alpha equal to 0.05, I wrote alpha twice, we reject the null hypothesis. We do have sufficient evidence that there has been an increase in the proportion of these Kachi plants that have been resistant to glyphosate. So I don't want anyone to get discouraged by what we've been doing. This was actually a problem in 2018 on the AP statistics exam. I want to make sure that we can handle anything. So typically, they will not give us percentages like they did here. They would just give us a numerator and a denominator, and you could fill it in. However, if they do, if you want to be precise, you will have to work it out using your calculator, but not using the stat test and going down to hypothesis test. If you did want to, stay with me for 2 more minutes. If you did want to, then you would have to round these numbers to 12.017, and to be honest, 12.017 is very close to 12, and 20.02 is very close to 20, so you probably will not get anything too crazy off. You'll probably be off by like 0.00 something. So you guys can check it out for yourselves. So I hope this was good. Take your time and slow down.